Now in this example, we want to calculate the effect size, which is also given by Cohens d, because sometimes we find out that we have a statistically significant effect. So for example, by saying that when we do a t-test, for example, we find that p is smaller than our alpha, and therefore we reject our null hypothesis, but we want to know whether the effect that we see is actually of any significance in practice. And here we have a two-sample independent t-test. We found that the two-sample means are statistically significant, and we get basically these data here in this table. And we want to know what is Cohens d for that. So Cohens d, and in this case, because we are dealing with two different samples, we can calculate the difference between their sample means. So that would be, I probably should write in this case, I should write x bar 1 minus x bar 2, x bar 2, so let's write it like that, divided by the average of the two standard deviations. So we can very easily calculate that. All we need to do really is calculate the difference between the sample means. So that would be the difference between 119 minus 109. That is the difference in the sample means, and we need to calculate the average of our two standard deviations. So that is the average of the two standard deviations. That's this one here. We do that with the average function. So here we have the average, and all we need to do for our Cohens d now is divide the difference in the sample means equals sample mean difference divided by the standard deviation, and we get a Cohens d of, let me write this down, Cohens d is 0.63, and we can say that according to the table that we had earlier here, we have a pretty large effect actually. So any Cohens d, so if the Cohens d, if the effect size, so if Cohens d is between 0.5 and 0.8, we can say this is actually not only statistically significant, but it is indeed a large effect in this case. And it's always good to give this Cohens d because it gives actually a good indication whether we need to worry about a statistically significant effect. Cohens d calculation only makes sense if our p-value is indeed smaller than our significance level.